Okay, so let's go. Okay. Okay, I think I was trying. I mean, to be honest, I was also doing topic 4 assignment last time myself. I think it took me about 1 hour plus, 1 hour each. But I went watch TV, come back. So I think if you started doing it, should be able to do. Quite easy, right? Quite easy, you don't have. Huh? Oh, Zhe Kai. So Zhe Kai is such a innocent young boy. Huh? Cigarette? No smoking. Okay. Okay, so let's look at 1A. You're supposed to solve modulus x plus 1 equals to 2x minus 3. So you know that when you have modulus equals to modulus is equal to f equals to g or f equals to negative. Okay? So 1A shouldn't be any issue. Okay, Sally, how about do? Okay. Anyone never do? All got do? Very good. Very good. Okay, I just want to, yes. You never bring. You pay me back with your guitar. Yeah. Can I? Okay, so what you got to do lah? It's okay lah, tomorrow give me. Okay, I just want to say that your results, actually this class, the results improved a lot. Yeah, actually it went up. So even for quiz 1, the ranking actually went up. I cannot tell the data lah, but the classes that y'all used to lose to, now y'all win the classes. By me. Yeah. So it also shows because it's consistent. Another class, one class also over swap places. But so when we talk, the math teachers, we talk every week. So actually I just talk with them. So what is consistent is homework submission. Yeah, so this class of homework submission is pretty good. When the submission goes up, then the results also go up. So it's one of the correlation. Okay? Can Aiden? Can I? Okay, so I go to 1B. 1B, there are 2 cases also, 64 and negative 8. If there are issues, please let me know. If not, please self-mark. Okay? Please self-mark. Xavier got do? Sadana, help me check. Xavier do how much? B. Yeah. Okay. See me got do? Well done. Okay. Cannot say. Yeah, I can't say. Yeah. But you are one of the highest. I think you're the highest. I think you are the highest. You are among the highest. You are the highest. There are a few people with the same score as you, but your mark is the highest. Yeah. Huh? It's the mark is the highest mark. There are people who got the same marks. Yeah. Which one? Yeah, I used to have a student called Mark Fu. You all know? So I used to teach him. You know basketballer? Basketballer Mark Fu? There was a basketballer called Mark Fu. Yeah. So I teach him. Then when he's after a Mark Fu one, you never get full marks. Okay, anyway, 1C, secant equals to cosecant, secant equals minus cosecant. Okay, so you divide by. From the first step to the second step, are you okay? You all understand why? Yes, you just take the reciprocal, that's all. Because you see, secant equals to cosecant. This is 1 over cosine, 1 over sine. Then you cross multiply, sine x equals to cos x. Okay, it's the same for the right hand side. Okay, you will get cosine x equals to negative sine. Okay? Yeah. Okay, also that's 1C. Final answer you get is pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. I hope you are marking. Can I? Archie, you write the answer down. Okay? All okay, ma? If you are not okay, you ask. So if you ask, you will I go through, it's also beneficial. Oh. So then after that, you realize that we need to reject 5 pi over 4 and 7 pi over 4. There's a reason behind this. The reason is because you realize that this is the question. In case you forgot, this is the question. The question is over here. There's a difference in the question. You realize that here, this is 1C. Okay? So for 1C, right, if you observe, is there any modulus around cosecant? Don't have. This means that one of the requirements is that you will need cosecant x to be more than 0. Right? Because this is equal to a modulus function. So far, okay? Can I? So because it equals to a modulus function, then you observe when pi over 4 and 7 pi over 4, this makes your cosecant negative. Okay, this makes your cosecant negative. This makes cosecant negative. Okay, okay. So I just say again, x, if you check, cosecant 5 pi over 4 is the same as 1 over sine 5 pi over 4. Huh? Okay. Can I? So therefore, you can only take x to be pi over 4 or 3 pi over 4. Okay? Can? This is less than 0. Okay, so this one I reject. This one I reject. Can yeah. Since cosecant x since cosecant x, no, you need to write down. You need to write down these two. So you write down, then you reject the two values. Okay? Can I? Okay, so yeah, okay. Any question? Yeah, see how I'm looking at the screen and copying, so I pause a while. Today, Dora not here. Okay. Want to see, okay? What do I owe you? I don't owe you anything. I owe you the recording. I owe you a power bank. Oh, yes, 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 yes. Actually, I've been uploading every week. Yeah, I just haven't had the time to. Please subscribe. Subscribe. Your loyal subscriber? You're a lawyer. I also want to be loyal. I don't talk so well. Okay. 2A, yes. Dora the Explorer. Okay, question 2. Question 2. Question 2, in case you forgot, this is the question. Okay, this is the question. All right, just look at the question first. This is 2A. Okay, now I try to make the question side by side so you can see. So 2A, if you observe, 0.5 minus sine 2x. So this itself, remember, modulus of fx is the same as modulus of negative f. So 0.5 mod can therefore be written as sine 2x minus 0.5. Now I choose to do it this way because this is easier. This is easier. Okay? Now because sine 2x I know what down, sine 2x minus 0.5 translate 0.5 downwards. So you know that sine 2x, the original graph would have been something like this. Sine 2x minus 0.5 would have been something like that. Okay? So, did I do it correctly? Yeah, okay. Oh, minus 0.5. So I would have gone down. For example, something. This would have been sine 2x minus 0.5. Okay? Then you see that this portion here is reflected up, this portion here is reflected up. Okay, huh? Yes. Try to have the middle intervals if you can. Yeah, so this line, okay, guys, just take note, this one you should have be present. Try to have the turning points. However, drop also need to have. Okay, endpoints need to have. If the domain is labeled, you need to have the endpoints. Can you just make sure that you all have all this and you take note? Okay, copy down. If the question, so here I'm going to write down, if the question has a domain given, as a domain, try to label the endpoints too. Okay, so here you also need to label the x-intercepts and turning point. Okay, you can label this way, either by dotted line, or you can simply label by coordinates. That you write it as 3 pi over 4 and 1.5. So far, okay? And so sorry, bear with me. I'm not going through very dry. Try your best. Try your best. This is pi over 4, 0.5. Okay? How many? Sorry, come again? Okay. How many answers for 1C? For 1C, there's a total of 2 answers. There are other 2. These 2, 5 pi and 7 pi, they will make cosecant negative. Okay, because when you sub in, cosecant 5 pi over 4 is 1 over sine. This is negative. Now, if cosecant is equal to a modulus, cosecant cannot be negative. Okay? Can I? So, next I come back to 2A. Any issue? So, guys, I just want to remind you, you need to have your intercept. All this must have, all this must have. Can you look at how the marks are given? Can you just take a look at how the marks are given? We will mark based on this. Okay, yeah, your exams are also based on this. Okay, this is also like A-level standard. Okay. So far, okay. Okay. Then I go to 2B. 2B should be quite easy. 2B, I don't think there's any thinking, not much thinking needed. But for 2B, can I just request that similarly, put in the effort to draw the graph properly. Okay. So you notice that -1 is being projected upwards to the asymptote y equals to 1. Okay. Do I know the intercepts? Unfortunately, I don't. So I cannot write the intercepts. This one, I don't know. Okay, but can I write the y-intercept? Yes, I can. Okay, can I write the asymptote? Yes, I can. Do I know x-intercept, Sean? You busy talking to Shivani. Yeah. Okay, yeah. Yes, you need to draw the dotted line. Connection. Or me to the left, You mean to the left? Do I have to continue the... Okay, to show asymptotic behavior, you mean? Like this? You'll be good to draw. It'll be good to draw. Yeah, it'll be good to draw. Good question. It'll be good to draw. It'll be good to draw. Okay, it'll be good to draw. Yeah. Yeah. If the graph, I didn't, because this question, the graph are simple. So I'm just afraid of being confused. Yeah. Okay, it'll be good to draw. Okay, but yeah, you can see I don't get any marks for drawing. So I think it's okay. It's okay. Okay. Yeah. Oh. Sundara Rajan Sanan. Okay. Can I? Question 3. Question 3, no issue lah, no issue. Okay, so 2x minus 4 modulus. If you are still confused what to do, step 1, sketch y equals to 2x minus 4 first. Then you rotate. Okay, then you pivot the point. Okay, then finally you reflect the bottom portion of the graph about the x-axis. Okay, can I? So this is the yes. Can I? Can I scratch? You want me to scratch you? Oh, go. All the best. Okay. Is your handphone with you? Okay, that's good. Okay, all the best. Presbyterian High is quite a strong school, quite strong. I saw NJC play with them quite a many years ago. No, wait, later. Okay, so this one is the question. Just think of this is the question. Okay, let me just shift this to the right. Okay, let me shift this up. Question below. Okay, now we are looking at this question number 3 part 1. Any issue? If the question has endpoint, okay, so I say again, if the question has endpoint, let's say example, they tell you to draw something like this, x between -3 to 3. Then you need to label. Okay, you label like 3, 2, -3, 2, something like that. Here so far, you heard me? This is for, probably quiz 2 lah. Okay, if the question has endpoint. Okay, so next I go to part 2. Find the intersection of any point, find the coordinate of the intersection of the line and the graph. Okay, where m is equals to 3. Okay, a gradient 3 passes through 0, -1. So that means this equation, what will it look like? This line, what will it look like? Pass through 0, -1, gradient m. That means the equation is like y equals to mx minus 1, right? Can I say that? So if m is equals to 3, your graph is y equals to 3x minus 1. Okay? So that is why you have the first equation, y equals to 3x minus 1. Intersect with the modulus graph. Intersect with the modulus graph. You solve simultaneously. Okay? After that, you get one answer. The other answer you need to reject. This answer you need to reject. This answer you need to reject. Okay, ma? So far, okay? The bottom portion about the y-axis, meaning about the y-axis and not the x-axis. Head. Yeah, senior high. So to add to your question, okay, Sadhana asks, okay, let's just write it here, okay? Is there any scenario? Is there any case where we have a modulus function and we rotate about x-axis instead? Sorry, you rotate. Sorry, not rotate. Reflect. Anyone got an answer to this? Ernie? Then you? What do you say? See his answer. Anyone heard what Alex say? Say again, Sean? Yes. So actually the answer, you learn it in senior high. It's a y. The way to do this, okay, I mean, is, okay, one function that we have not gone through before is f modulus x. Okay, well done, Alex. Can I just write it here so that it appears on my YouTube channel? Well done, doing high. Okay, can So f modulus x, what will happen? Okay, if the graph, let's say fx looks like this. Fx looks like this. Like that. Okay. So this portion is where x is positive. But if you are taking modulus x, what are you trying to do? You want x to be positive, right? So what will happen if you are drawing? Okay, this one not a syllabus, guys, just for info, What will happen? You basically keep the right hand side. Your graph will look like this. That means I'm taking just the right hand side. Because the right hand side is where x is positive. I'm going to reflect it about the y-axis. The portion where x is negative is no longer around. Because once you do this, right, once you do from here to here, right, f of -3 is considered the same as f of 3. F of -5 is considered the f of 5. That means, think about it, f of -3 is the same as f of 3. F of -5 must be the same as f of 5. It has to be a mirror image around the y-axis. Okay, that's a fun fact. You will learn this in senior high 1, not now. I think over to the right side. Meaning, okay, so here I use the modulus inside. Inside means we only want x to be positive. We only want x to be positive. Only one. So it doesn't matter whether y is negative. Correct. Dotted lines over here. Here. Reflected to the right side. Because the graph is totally gone. This is totally gone. It's totally gone. It will not even, so it's a different operation altogether. It will not be reflected. It's totally gone. Yes, it's a totally different thing, right? It's a totally different thing. That's why we never teach that, But slowly senior high 1 will learn. Don't need to rush, Yeah. But since you all ask, then go through. No harm learning, man. You never know. Study okay, so 3. Okay, when you have a graph, the line is of gradient m and it passes through 0, -1. Okay, 0, -1. Yeah, do I have a 1 second? X plus 3, for example, and you look at modulus x. Can you see the red and the blue? Can you see the red and the blue? So this is the red color is fx. Blue color is f of x. What happens to this portion? It's no longer around. This part is reflected of the y-axis. Okay. And now, because we can only take in negative positive x values. Yeah, it is okay. Later I talk more about it. Okay. Back to the question. So I shift down. 3. When will the line intersect at 2 points? Salihan, stay away. When will the line intersect at 2 points? So you can see that here, this gradient is 2. Okay? This gradient is 2. Now, if you observe, right, this is the line. Well, how many times will it intersect? Only 1 time. Only 1 time. Okay, so what you see is, okay, basically this line, you will pivot between here and here. Okay, you will pivot between here. So you see this line. Okay, just like the question, just like the question. When will it intersect between? It's a similar to the golf ball question that we did in the notes. Okay. So I just show you. This is the black. Now I have the red color, right? Now this gradient is 2. How many times do I intersect? 1. So the gradient must be less than 2. Then I will intersect 2 times. Can you see? Can. So it can be less than 2, less than 2, less than 2. It can be 0. It can be until here. Almost, so it has to pivot. It has to pivot around this point until half. Half. See, when the gradient is half, how many times I intersect? I go less than half, no more. So that's why it's the pivoting around this point, right? You can see, the gradient is between 2 to half. Okay, less than 2 in order to intersect once. That's the idea, lah. Okay. No need. Actually, just write out word 2. Okay. Okay. Which answer is 1 mark. Answer is 1 mark. Probably left maybe 1 mark, right? Maybe 1 mark. Okay. Correct endpoint. 2 points. Can. Okay, ready? I go on. Okay. Oh, yeah, everything. Do you need me to explain? I can say the whole thing. I can say the whole thing today. Right after this. After I go through, more or less after I go through today, I should be okay. So it's okay, I'll stay where I am. Or I scared I move the iPad, then the net will be spotty. I sent to Kate and Zekai. So Kate and Zekai, can you send to whoever you can send to? Yeah. Sadhana, I think I sent. I saw 2 Sadhanas. I think it's Sadhana's sister. Hey, whose username is hot single? Okay, I don't want to say. Isabella, what's your passport? Are you the one? Are you the hot single mom? Okay, I hope it's not you. No, it's not you. Who's that? Whose username is this one? Kang Yu. Huh? Joshua? Joshua, what's your username? What's your username? What's your username? Read out to me what's your username. Okay, read out to me what's your username. Okay, can you change it? Okay. Have you changed it yet? Okay. Who's iPad 2? No, Archie. My car rejected this. Okay, so I go on. Question 4, part 1. Okay, sketching the graph of modulus x squared minus x minus 6. Okay, so you guys, if you see the Negative 3, 6, 5, 14. Okay, yeah. So you notice this question, there's a limit, right? But the limit is not inclusive one. It doesn't include negative 3 and 5. Negative 3 and 5. Okay? Can? Yeah. So this is for part 1. Please remember to include the endpoint. Now in this case, the endpoint is an open circle. Can I just bring this to your attention? The endpoints, they are open circle. Why? It's because it is not inclusive. You all understand so far? Can I? A lot of people minus marks because of this endpoint. Okay, so guys, you see endpoint got marks on. Can I? Can I? Okay. So now this and a suitable line. Now if I look at part B, right? This is the same as solving x squared minus x minus 6 equals to 1 minus 3x. Okay? So this itself, you put it, draw this line. Draw this line over here. Draw this line over here. And yeah, you know, now you probably need to solve it manually. Can I cover the graph? One looking. Okay. So you notice I solve simultaneously, right? And after which, right? Okay, after you solve, you realize that you have two answers, right? You have two answers, right? Based on the graph, you can see that which answer will you take? The negative one or the positive one? I take the positive one. I take the negative one because x is supposed to be minus 1. Oh, okay. So remember here, the x coordinate is negative. The x coordinate is negative. Agree? On this side, then the x is positive. Okay, all? Yeah, yes. Where are we supposed to give the okay? If you ask me, personally, when I do questions like this, I give it all the time. All the time. That's to be safe. Yeah, I always give more. Then it's no issue. Oh, but if they just ask to solve, actually, by right, the x value is enough. So we reject 5. The answer is minus 1. Okay, ma? Dora, okay? I saw you put your eyes at the time. Okay, okay. Okay. Emily, okay? Peter, okay? Peter praying, okay. Okay, for part 3. So then I want modulus x plus. So you can see the difference between this and this. So this will be translated to, this is the same as looking at x squared minus x minus 6 more than 1 minus 3x. What does more than mean? Am I above or below you? If the y value is more than, am I above or am I below? Above. So that is why I'll be looking at the, okay, let me color them. Pink above yellow. So this is your pink above yellow. When is pink above yellow? This portion, where x is more than minus 1. Okay? So straight away, when x is between minus 1 to 5. Okay, x is more than minus 1. All the way up to 5. Okay? Why is there up to 5? It's because the definition here is only up to 5. Okay, yeah. So if you just write x more than minus 1, not enough. You need to include the right limit, which is 5. Okay, because the function for part 1 define up to negative 3 to 5. Okay, so for part 1, 6.25 to 14. Yeah, for part 1, I want to have k. What kind of equation is k? What kind of line are we talking about? Horizontal line. Very good. By now you all are due now. So this is basically this is the curve. This is the curve, and this is a horizontal line. This is a horizontal line. Y equals to k. Now you want this to be having one solution. One solution means one intersection. The horizontal line one intersection. Okay, where can my horizontal line get one intersection? Above here. Can you see? Basically above this turning point, I will cut only one time. Above this turning point, I will cut only one time. That's why the answer is just 6.25 to 40. Okay, which is basically from here all the way up to the end point here. The end point here is if you saw the end point here is okay. The end point here is up to 40. Okay, and between this area, the horizontal line will only cut once. Okay, where will the horizontal line cut twice? 0 or 6.25. When it's equal to 0, you can cut 2 points. When it's equal to 6.25, okay, when it's equal to 6.25, you will cut 2 points as well. Okay, does it cut here? No, it doesn't cut. So that's why you must 1 and 2. Where is it? 3 times between 6 to 6.25. Where is it 4 times between 0 to 6? Yeah.
6
equals to K.
It's like 6 everything.
No, there will only be 3.
1, 2, and then they cut
1, 2, 1, 2. When it's equals to 6, right?
Yeah.
When it's equals to 6, you see I cut 1, 2, 1, 2, 3. This one doesn't cut, it's an open circle. So I only got 3. Oh, but it's a good question. Thanks for mentioning this. Okay, then pay attention, stop looking at Emily's bottle. Okay, then please bottle up your feelings. Okay. Okay, so this is a question for part 4. Okay, ma? Easy to do, but not easy to go through. Okay, there's a lot of thought behind. Stay focused, stay focused. Okay, coming to the last question already. Last question, easy. Last question, easy. Not really. Yeah, it can be reduced. It can be reduced. Because I believe your 5 you can get for 5 part 2. Okay. Okay. So I go to 5, draw the curve out. I don't think endpoints are needed because there's no domain, no restriction in domain. What you will need to take note is, guys, there's an intersection here. Okay, as long as you have 2 functions where the gradient is different, it's bound to intersect. They are bound to intersect one day. Here, so it will be ludicrous if you don't show the intersection. You lose the mark. Okay, a lot of students, I saw they were not they didn't put it in. They didn't draw the full graph. So you must remember, draw properly. Okay? And got student I see never draw the intersection already. Here, 1, 2. There should be 2 intersections. Cannot see. Okay. I got see student never draw. I got see student only draw 1. I got see student using invisible ink. Okay. So guys, this graph is not as simple as it looks. Can you check your partner's work? Are there 2 intersections? When they check Yong Kai's work, please check Aki's work. Madana, are you check Alia's work and Xavier's work? Xavier do already? Xavier using invisible ink. Okay, Xingyu, okay. Xingyu, good. I saw, good. Okay. Hayden, check Dora, check Jialin, check Emily, check Zekai. Good. Okay. Can guys, is there 2 intersections? No, is there. Are there 2 intersections? Have? So make sure, I will just say this again. When you are drawing a modulus graph, when there's 3 and there's 2, and you're not sure if the set, as long as the gradients are different, there will be intersection. Okay, common mistake, it's a solve. Common mistake I see students do like that. Some students draw like this. Okay, So please do not show lack of effort or sluggishness in drawing your modulus graph. 5 part 2, just solve simultaneously. Solve simultaneously. But basically, the concept is if fx equals to gx, f equals to g, or f equals to negative g. Solving both answers, you can see negative 3 and negative 1 over 5, they are basically over here. I will write that in orange. This is negative 3. This is negative 1 over 5. Okay, we are looking at this region over here for part. Can you see? I'll use yellow, I'll use yellow. Huh? Xavier, what question you at now? 1B, 1B, 2, 1C, 1C. Salihan, okay. Any part you know. Tyson, okay. Join the graph. Okay. Okay, then I go to 5 part 3. If you observe 5 part 3, it's slightly different from 5 part 2. Okay, it's a deduction. So what's the trick here? The trick here is to divide by modulus x. The trick here is to divide by modulus x. This is the punchline. Yeah. You managed to get the same answer. I think can. Yeah. Huh? Okay. And that was. Okay. Yeah. I think there are many ways to do. If you square both sides, use substitution. That's okay as well. Okay. So 5 part 2, 5 parts. Questions? If you are okay, then let me give you about 5 minutes to do your correction. Then we'll come back to topic 5 notes. We'll look at question 3.6. Yeah, the very difficult question. Can. Hey, you also go restroom. Dora, go to. Which are you going, here or here? When you go outside, can you look at the poster? Tell me what's the acronym. Are you going to the toilet? You go there. When you go there, look at the water cooler. Can you tell me what's the acronym on the poster? Huh? Living. Okay, bye-bye. Okay. Let's check who's doing correction now. Okay, those who are done, can you take out your topic 5? Huh? No, it's not a break, it's for you all to do your correction. Yeah, it doesn't mean break, you can put on earphones. Nobody ever said this. No teacher ever allowed this. Okay? Yeah. Please don't jump to conclusion. Okay, yeah? Mr. Jason Lee. Yeah. No. Okay, let's go. Hey, why all go toilet? No, all sit down. All sit down. Why all go toilet? This is a short break. Okay, go. I gave you all 2 minutes, come back quick. Okay. Okay, wait. Go to that toilet. Look at the poster and tell me what the poster is. Once you're done, can you pass your homework to Tyson? Yeah. Young Kai, if you're not looking at math stuff, I suggest you're close. Yeah. Are you supposed to be doing other things now? What are you looking at? What are you looking at? What are you looking at? Huh? Showing the history for what? Now, doing math lesson? Sit down. I don't want to talk to you. I'm very pissed off. Huh? Yeah. One lesson, I need to correct you 5, 6 times. Yeah. I'm also tired. You look at other students, just look at how other students behave. Okay, I'm okay.